Hello everyone, thanks for joining. My name is Eleonora Rusconi. I'm a material scientist, but today I'm also your host in this short video where I'm gonna talk to you about the Heat for Energy project. Let's start.
Heat for Energy aims to transform low-grade waste heat into electricity. With the expression low-grade waste heat, it is identified heat with a temperature lower than 100 Celsius degrees, which is produced by human activities and which is dispersed into the environment after conversion of the primary energy carriers. Now, let's stop for a minute and let's bring in some numbers. More than the 70% of the energy resulting from conversion of primary energy carriers gets lost, of which the 63% is released into the surroundings as low-grade waste heat. Let me now explain you how. The technology is based on the thermomagnetic cycle and the Faraday's law of induction. Future devices will exploit the so-called thermomagnetic materials. These materials are such that their magnetic properties and their temperature are intimately interrelated. For example, the magnetization can be modified by heating the material up or cooling it down. In a thermomagnetic cycle, thermomagnetic material are actually stimulated by a variation of temperature and application or removal of an external magnetic field. Here comes my contribution to this project. As a PhD in material science, I will look around for good material platforms and I will synthesize them as bulks and films for applications at different length scale from micro to macro. I am based in Parma, Italy, where I work at IMEM, Institute of Materials for Magnetism and Electronics. During my PhD, I will also travel abroad, namely to Germany and to the Netherlands, to join 3 of the project partners: Karlsruhe Institute of Technology and TU Delft, 2 partner universities, and the startup Magneto BV. But let's get more specific about my research work. I will investigate the Heulser family in order to spot good candidates for our future thermomagnetic devices. Heulers are alloys with general formula X2YZ, where X and Y are transition metals and Z is a p group element. Generally, atoms organize in a cubic structure. However, the lattice of the so-called metamagnetic Heulers is sensitive to the temperature. Their cubic phase, known as austenitic phase, transforms into a lower symmetry lattice when the material is cooled down under a critical temperature value. The resulting structure is named martensite. Similarly, the magnetic order existing in each phase is determined by the temperature of the material. At the Karlsruhe Institute of Technology in Germany, I will interact with engineers. In fact, the films previously deposited in Parma will be embedded in a thermomagnetic device aimed for micro-harvesting. In turn, micro-harvesting will be used in micro-applications.
For example, think about having a watch that recharges itself by using the heat emitted by your body. In Netherlands, I will first join TU Delft, the University of Delft, where we will develop melting techniques for producing bulk materials. I will join Magneto BV, a startup which uses 3D printing to scale up materials production.
Thanks for watching!